Okay, let's continue with example 1 here. So we've already found the y-intercept on the concavity. What we were also asked to find is 2 additional ordered pairs for this quadratic function. An ordered pair, remember, is a coordinate x comma y. So 2 of these that work in this function. Okay. Whoopsie. So we know that f of x can also be replaced by y. They mean the same thing. So let's write that out here. Y is equal to the function that we have. Now we have 2 variables, the x and the y, in our function, which means it's graphable. Now we just need to pick any number to put in for x, and we'll see what we get when we do that. The easiest one to pick would be 0. So this is the list of the x, here's the y's. If we put a 0 in for x, probably don't need to write this all out, but I will just to show you, because multiplying by 0 is easy. Y equals 0 plus 0 plus 8. Y equals 8. So when x equals 0, y equals 8. That creates the ordered pair 0, 8. So there's one. And then you can pick any other number. You could pick 2000 to put in for x if you want, any number. The next easiest number would probably be just a 1. So let's put a 1 in for x. Again, you could probably do this math in your head, which is plus 8. 2 times 1 is 2, plus 8 times 1. So we're at 10, plus 8, 18. So our ordered pair here is 1 and 18. Now it only asked us for 2 additional ordered pairs, but you could go on forever, and then you could plot the points and easily draw the parabola. Okay, in the previous example I just finished with, you could easily draw the parabola, and that's what they're asked to do here. Okay, so let's set up a same chart so we can find some coordinates and plot this parabola. The parabola is y, or f of x, equals x squared plus x minus 2. We need to find the x coordinate and the y coordinate. We'll start with the easiest one first. So we put a 0 in for x, and we just get y equals -2. Perfect. Let's try 1s. So we put a 1 in for x, and we get 1 squared is 1 plus 1 minus 2. So 0. Put a -1 in, we'll get -1 squared will be 1, subtract 1, subtract 2, will be -2. And let's do one higher. I don't know, does our thing reach till 10? I think so. Let's just go with a 2. So 2 squared would be 4, plus 2 minus 2 gives us a 4. And let's try minus 2, and we'll have, why is it doing that? 4 minus 2 minus 2 is 0. Okay. Okay, so if you can't see them, we'll write our x and our y coordinates here. That's 0 is the x and -2 is the y. 1, 0, -1, -2, 2, 4, and -2, 0. You don't need to write these. I'm just helping you to see the coordinates. So 0 on the x-axis, x and y. 0 on the x-axis and -2. That looks like our y-intercept right there. We've got a 1 and a 0 here. We've got a -1 and a -2. You've got a 2 and a 1, 2, 3, 4 on the y-axis, and a -2 and 0. Okay, I can kind of see what's going on here. Can you see it? So it looks like our parabola is going to go like this. And yeah, somewhere like that. That's a sketch. Okay? You can see that the lowest point is going to be right here in the very center. We've got here an x-intercept, and y-intercept. We've got it obviously opening up. And we've got an axis of symmetry. I shouldn't have written the word up there. It's going to go right through it, down the very center of it. Okay, so let's answer these few of these questions. The y-intercept happens at 0, -2. X-intercepts are at -2 and 0 and 1 and 0. The equation of the axis of symmetry is at, so it looks like a -0.5. It's at the spot where x equals -0.5. The coordinates of the vertex, v, is equal to, I don't exactly know how low it goes. We're going to have to figure that out. Okay, I can eyeball kind of how low it goes, but I can't figure that out, so we're going to have to put another spot. We said the axis of symmetry happens at -0.5. So what happens when I put a -0.5 in for x? We need to know what that y value is. I'm going to square it. Remember, this one we might want to do on our calculators. Okay, we do that on our calculators and we get -2.25. So the vertex, that's the y coordinate of that spot. The vertex happens at -0.5, -2.25. Okay, and that's that. Now it's asking for the domain. The domain equals, well, now the possibilities for x are endless. We see these purple arrows on the parabola going up, and really they could go up and up and up. So when we're wondering where on this x-axis, we'll have coordinates, all real numbers, anything. The range, though, will have some restrictions because we see this parabola is at -2.25 on the y-axis or higher. So this y such that y is going to be greater than or equal to -2.25 in squiggly brackets. Excellent. Okay, here's example 2, our last example. Let's think about this a bit. So you can already imagine by the picture that we've got water spraying from a hole in the ground at a splash park. They have a beautiful kids splash park by the river in Saskatoon. Anyways, you can imagine it sprayed straight up, right, and then coming down in a parabola shape. Some children are playing at the local splash pad. The water jets spray from ground level. The path of the water from one of these jets forms an arc that can be defined by this function. Okay, right here, it's telling us the quadratic equation. The path of the water from one of the jets, okay, sorry I read that already, where x represents the horizontal distance from the opening in the ground in feet, and f of x, also meaning y, right, that's the y-axis, is the height of the water sprayed, also measured in feet. What is the maximum height of arc of the water, and how far from the opening in the ground does the water reach? Okay. I'd like to move this out of the way because we're not doing that question right now. Okay, let's think about this. We have got our x-axis and our y-axis, and this is 0. Why don't I need to draw the other quadrants of this? Because the water doesn't spray beneath the ground, nor does it go. We only need this quadrant where things are positive. So the water sprays up like this and down. It's pretty close. And it sprays up right from 0. The question is, how high does it get in feet? And how far does it get in feet? And it's given by that formula. So let's set up a table of values here, and I've started already. If we put a 0 in for x, we're going to get a 0 for y. That's what the graph shows. That's this first point. 0 and 0 is definitely on the graph. It told us that in the question. So I didn't try 0. I started with 1, then I started with 2, and then I'm like, whoa, I think it's going to be higher than 5 feet. So I put in a 10, and when I put in a 10, then let me write down the work. 1.2 times 10 squared, so times 100, plus 30, 3 times 10, gives me 18. Let's try 12, and I get 18.72, getting closer. I'm not sure where it's turning down yet. Let's try 15 and see what we get. So when I try 15, I get the value 18. Okay, so I can see 12 feet for the x. I don't know if that's its max, but for sure at 10 and 18, 10 and 15, it's both 18 high. So let's write this on our graph. I'm not exactly sure where, this might be 18 right here, very close to the top. And right here, that happens at 10. So when x is 10, y is 18. And also when x is 15, then y is 18. Okay, so we know this gives us a lot of clues. We know the vertex then is the maximum point of this spraying of water, happens at that exact point. The point right in between 10 and 15, which is what? 12.5 feet. Okay, let's try 12.5 now, because we don't know exactly what y is. So let's put in 0.12 times 12.5 squared plus 3 times 12.5. What do we get there? We get 18.75, just a tiny bit higher than it was at 12, which does make sense. So our height, 18.75 feet, is the maximum height. Okay, that answers the first question. The second question was, how far does it spray? What's this distance here? So if exactly half is at 12.5, what are you thinking? Yeah, 12.5 times 2. That, now our diagram's not exactly accurate, but it tells us what it needs to. 12.5 times 12.5 is 25 feet. So it reaches a distance of 25 feet and a height of 18.75 feet. Pretty cool to be able to analyze the parabola of spraying water. Okay, you can proceed to your assignment, which now that I look is right here. Good luck.